Here we go, section 3.3 on special angles. Special angles are ones that occur most frequently, obviously. Not obviously, but they occur probably the most frequently, and they are required of us to find exact values. Since we often round off decimals, they're not exact values. With these special angles, we want and require exact values, okay? The first ones we're looking at are what we call quadrantal angles. They are the ones that occur on the axis when the terminal arm is on the x or y axis, okay? That means that we're basically looking at theta when it's 0 degrees, 90 degrees, 180 degrees, and 270 degrees, okay? And what I find useful in explaining these special angles is looking at what we call a unit circle, okay? And this is when we have a circle of radius 1 unit, okay, centimeter, meter, whatever you want, and the center is at the origin. This is the situation that I'm talking about, okay, unit circle. So you have a radius of 1 all the way around, which means that when you're here, it's at 1, 0, the x, y, x is 1, y is 0, x is 0, y is 1, x is negative 1, y is 0, x is 0, y is negative 1, okay? What we can also do is break this down into its component parts. So this is the x and that's the y, okay? So notice that as we come down, okay, so let's identify these things first of all. So we know that r is equal to 1 in this unit circle, okay? Don't forget that r is always positive, because if we do Pythagoras, x squared plus y squared is r squared. Everything's squared, everything becomes positive, so my r value is always positive, okay? It's the x that changes from positive to negative, and the y that changes from positive to negative. Okay, so if we look at the sine theta, we'll put theta in here. It's the opposite over the hypotenuse. It's y over r, which is y over 1, which is y. So in a unit circle, your sine is equal to the y value. Similarly, with the cos, it's x over r, or x over 1, or simply x. The cos is equal to the x value. And tan is always y over x. That doesn't really change. It just stays as y over x, okay? Because those things change. The r remains constant. Now, what I want you to think about is what happens to your x and y values when you're down here, okay? If you bring this arm all the way down, all of a sudden your x is 1, your r is 1, and your y is 0, right? So we can plug those in here. If your x is equal to 1, your y is equal to 0, your r is equal to 1, well, we can start doing finding the values for sine 0, cos 0, and tan 0. Sine 0 is y over r, so it's 0 over 1, or 0, right? Your cos 0 is x over r, 1 over 1. That gives me 1. And your tan 0 is y over x, so 0 over 1, and that gives me 0, okay? Now let's move up to here. Let's bring this up here to the top. Well, once we get up here, look, our x is 0, our y is 0, and my r is 1. Sorry, my y is 1, not 0, my y is 1. Okay, so if we look at sine 90, sine theta, right, it's y over r, so it's 1 over 1, which is 1. And if we look at the cos value, cos is x over r, 0 over r. So 0 over 1, which is 0. And tan 90 is y over x. It's 1 over 0. Since we have division by 0, we're not allowed. If you do it in a calculator, you should get error, but we call it undefined. Okay? Now think about what's going to happen in this quadrant, or at this point here and this point here, okay? Identify your x, identify your y, identify your r. See if you can come up with some numbers down there. Pause it, give it a shot. So your x is negative 1 here, your y is 0, and your r is 1. So if we look at the values for sine 180, that's y over r, 0 over r, 0 over 1 is 0. Cos 180, x over r, negative 1 over 1, which is negative 1. Tan 180, which is y over x, so 0 over negative 1, again gives me 0, okay? okay? The last one here, look at the x value, it's 0, the y value is -1, and the r value is 1. So if we look at sine 270, y over r, -1 over 1, which is -1. Cos x over r, x over r, 0 over 1, which is 0. And tan 270, y over x, so -1 over 0. And again, division by 0 not allowed, so we have this thing called undefined, okay? In your textbook, they show an infinity sign as well. So these are the quadrantal angles. You can memorize this table, summarize it yourself, or just be able to work it out using that picture, okay? So those are one special type of triangles. And the next one we have, here we go. Next ones we have are what we call special angled triangles, okay? These are two special types of triangles. One's an isosceles triangle, one's an equilateral triangle. I can explain to you a little bit how they come about in the class. I'll try a little bit right now too, okay? So the first one we're looking at is a 45, 90 degree angle, okay? That means that these sides are the same. You probably understand that from the characteristics of a 45, 45, you know, if those are the same, then those sides have to be the same. It's an isosceles triangle with a 90 degree angle. If we looked at putting an axis here, right, this would be the theta that I'm looking at. So when we start putting numbers on here, what we want to know is the ratio of the sides. So since these are the same, and we can put any number we want right there, we want the most reduced ratio that we can find. So what we do is we just put a 1 here, a 1 and a 1. And if you want to find the hypotenuse here, we can simply do as Pythagoras, which is 1 squared plus 1 squared is equal to h squared. That means 2 is equal to h squared. That means h is equal to root 2. So this side here is root 2. So anytime you have a sine of 45 degrees, what's sine of 45? It's 1 over root 2. What about cos 45? 1 over root 2. What about tan 45? 1 over 1, which is 1. Okay, so for a 45, 45, 90 degree angle, whenever you see sine 45, basically, it's always going to be some number. Tan 45 is always going to be the same number. Now, why we're doing this is because this 45 degree angle, don't forget that repeats here. That could be 45. Boom, that repeats here. That's 45. Boom, that repeats here. That's 45. Boom, that repeats here as well. That's 45. Now, what are all the angles? So this one's 45 degrees, but how big is this, right? That's going to have the same thing. So it's 180 minus 45. This is 135 degrees. So if you actually look at your calculator, right, sine 45 is equal to 0.707. Well, sine 135 is 0.707. So it's the same thing, right? Whether you're here or here. So now, if this reference angle, 180 plus 45, this is 225 degrees. And this is 360 minus 45, so this is 315 degrees. So they're always going to equal 0.707, but with sine, and then you got to remember that these are all sine, tan, cos things. Okay, so we're going to get to these types of questions very shortly. I just wanted to quickly show you what that's all about. Now, the next special angle triangles we have. Oh, here you go. This is a question I wanted to ask. What angles in standard position have a reference angle of 45 degrees? Well, that's essentially what we just did right here, okay? These are the 4 angles. All these have the same reference angle of 45 degrees, okay? Which means that if you want to find the ratio, it's 1, 1, and root 2 here. Or, yeah, we'll get to those questions. Yeah. Now, the next triangle we're going to look at is a 30, 60, 90. And this is an equilateral triangle. If I was going to put an axis on here, I'd probably put it down here, boom, boom, right? Where this is my angle. Now, if it's an equilateral triangle, it means all sides are the same. This angle, therefore, has to be 60 degrees, right? Now, it's a bit of a strange one, this one, because I say 60, 60, and 60. I don't have a 90. Well, what we do is we cut this in half, make that a 90 degree angle, and if that's 60, that means that that's 30 degrees up there, right? So now, let's look at this 60, okay, 60-degree triangle right here. And let's put a 30 up here. So it's the same thing, I just took it out of the thing. We're just looking at half of it, right? Now, if we wanted to call the smallest side 1, because we want the lowest ratios, right? That is this side here, so this side is twice as big, right? Because that's half of that side, half of that side. This is twice as big as that. Now, if we did Pythagoras, we'd have 1 squared plus, let's call that x. X squared is equal to 2 squared. That's 1 plus x squared equals 4. That's x squared equals 3. So x is equal to root 3. So what we have now is a 1, 2, root 3 triangle. Oops, my pencil ain't working. Here we go. Root 3. Okay, so this means that we have situations now where we can solve for sine 30, cos 30, tan 30. And here we are. Sine 30, looking up here, opposite over hypotenuse, boom, 1/2. Cos 30, adjacent over hypotenuse, we have root 3 over 2. Tan 30, 1 over root 3. Okay, now if we look at sine 60 now, root 3 over 2. Cos 60, 1/2. Tan 60, root 3 over 1. Or just root 3. Okay, so these triangles right here, these 45, 45, 90s, these 30, 60, 90s, I have tables that will summarize all this info. I think if you understand how to generate these, then it becomes significantly easier to remember as well. Let's go over a couple questions, and hopefully we'll make some sense of this. So let's see if we can find exact values for sine 210. So the key here right now, guys, is to find out what your reference angle is. Sine 210, 180 here, 210 would be here. That means that if I'm at 210, this is a 30-degree angle. Now, if you remember the 30-degree angle, okay, look at this 30-degree angle here, okay? The opposite side is 1, and the long side is 2. So, opposite side is 1, long side is 2. This side would be root 3, okay? So, it's just like this triangle, it's just in a different orientation, right? 30 degrees, opposite side is 1, hypotenuse is 2. Opposite side is 1, hypotenuse is 2, the other side is root 3. So now if I want sine 30, sine 210 is the same as sine 30, okay? So sine 30 is equal to 1/2. 1/2. Now you got to figure out, is this positive or negative? Now, if you look at the all sine tan cos thing, you'll see that sine is not positive down here, so it's equal to negative 1/2. Right? So what you can say is that sine 210 is equal to negative sine of 30, which is negative 1/2. I don't know if that makes sense to you or not, but you just got to figure. Okay, so let's try another one. I'm going to give you I'll give you a few minutes or a second to give it a shot. Here we go. So find exact values for cos 315. You got to find out where it is. Maybe pause the video, see what you can come up with, okay? So 270, 315 is going to fit right in here. That means the reference angle always measured to the x-axis is 45. And now I have a 45, 45, 90 triangle. And if you look at this 45, 45, 90 triangle that we have from the notes, I just flipped it around a little bit. Oh, let's flip it like this. How can I get it in there? Let's move this down. So see how this now is the same as that. So 1, 1, root 2. Okay? It's just in a different orientation. So 1, 1, root 2. Now, what is cos 315? Well, cos 315 is the same as cos 45, right? Which is 1 over 2. And then you got to figure out the sine. All sine, tan, cos, right? So all sine, tan, cos. So cos is positive here. So cos 315 is actually equal to cos 45 because everything's positive up here. Since they're both positive, there you go. So cos 35 is equal to cos 315, and they're both equal to 1 over root 2. Next up, let's see if we can find another question here. Tan 120. I got a couple more questions here just to get you, give you a good head start here. Boy, the lead keeps flying out of this pencil. Let's try again. So tan 120, first of all, sketch it, right? So 90 degrees, 180 degrees, 120. So my reference angle, if this is 120 degrees right here, 120 degrees, right? Boom. There's my right angle. 120 to 180 is 60 degrees. So 30, 60, 1, 2, root 3 is where the numbers are going to go. Now I'm looking for tan 120 is equal to tan 60, which is root 3 over 1. Now, all sine, tan, cos. So if sine is positive here, it means that tan is negative. So tan, sorry, this should be tan 120 degrees, is equal to the negative of tan 60, which is negative root 3 over 1. So negative tan 60, which is negative root 3 over 1, which is just negative root 3. Okay, we'll have a lot more practice doing this tomorrow. If you just ask me some questions, you know I'm going to help you out. All right, a couple more here, 3 more looks like. Here, let's find all the angles where sine theta is equal to root 3 over 2. Notice that's a positive. So if you look at your special angle triangle, root 3 and 2, which of these deals with root 3 and 2? You'll see that it's a 30, 60, 90 triangle. Okay, so let's draw that up. Let's draw up a 30, 60, 90. Okay, 30 degrees. Short side is 1, long side is 2, other side is root 3. So root 3 over 2, root 3 over 2. Opposite over hypotenuse, which means you have to be looking at this angle. Root 3 over 2, root 3 over 2. That's opposite over hypotenuse. So it means that theta, the reference angle, is 60 degrees. Okay, so if our reference angle is 60 degrees, well then that's 60, that's 60, that's 60, that's 60. So this first one here is 60 degrees. 180 minus 60 is 120 degrees. 180 plus 60 is 240 degrees. 360 minus 60 is 300 degrees. Now this is a positive root 3 over 2. All sine, tan, cos. So what we're looking at are these two up here. So in this case, theta is equal to 60 degrees and 120 degrees. Okay? I know it's kind of wacky. We'll get it though, don't you worry. Find all angles where cos theta is equal to negative 1 over root 2. So 1 and root 2. Which of these uses 1 and root 2? So 1 and 1, but this has a root 2, that doesn't have a root 2, so it's a 45, 45 triangle, right? So let's make a 45, 45, 1, 1, root 2, and 45 degrees. So cos is 1 over root 2. Okay, well let's draw a thing. 45, 45, 45, 45, 45, 45, 45, 45. All sine, tan, cos. So that's 45 degrees. That's 180 minus 45. Gives you 135. That would be 225. This would be 315. You want to know where it's negative 1 over root 2. All sine, tan, cos. Positive cos, positive cos. So we're looking at these two. So in this case, theta will equal 135 degrees and 225 degrees. I think there's one last question, folks, if you can bear with me. Find the smallest positive angle where sine theta equals negative 0.656. So this is a ratio here, okay? This is a given ratio. What I need to find is the reference angle. So you go sine negative 1, just of the positive version. Okay, so we go second sine of 0.656, you get 41 degrees, okay? So that means that theta r is 41 degrees. So 41, 41, 41, and 41, all sine, tan, cos. It's a negative 1, okay? They're looking for a negative 1, so it can't be these two. So I'm looking at this one and this one. It says the smallest positive, so it would be all the way around like this. 180 plus 41, theta would be 221 degrees. 180 plus 41 degrees. Folks, that's basically it. Okay, you might have a little bit of difficulty with this stuff. All you need to do is ask questions, but primarily you have to try. Okay, plug away, folks. Ask me some stuff tomorrow.